This module covers two related topics, risk analysis and inherently safer design, at the fundamental level. There is an exercise that will begin at the end of the risk analysis section and that will run throughout this module and later modules. After the section on inherently safer design, there will be an interactive session with the instructor. There are some exercises that can be done individually and some that are better done in groups. The first section concerns risk analysis. This section builds on the work done in the corresponding core module. We will refer to some of the principles discussed earlier, but will not repeat that work. There are 4 learning objectives in this section. The first is based on risk-based process safety, which is the current generation of process safety management, which was developed by the Center for Chemical Process Safety in the 1980s, and which is now commonly used in several different forms and adaptations across much of the industrialized world. This learning objective is based on an overview of RBPS, which is provided by the CCPS. We will be seeing how we can explain the relationships between the elements and between elements and pillars or foundation blocks in RBPS. We are not going to be getting into a detailed discussion of each element. That is available in the overview, which will be provided to you. In the second objective, we will be looking at the main quantitative and semi-quantitative risk analysis methods and their applications, and we will be describing them and showing how they can be used. The third objective will be describing commonly used methods for estimating frequency and consequence of failure. From the core module, you will remember that risk is frequency multiplied by consequence. After we've accomplished those 3 objectives, we will apply risk assessment to the exercise that will run throughout this module and further modules in the fundamental course. We briefly discussed risk-based process safety in the core module, considering the 4 pillars or foundation blocks on which RBPS rests. Now we're going to go beyond that and consider the 20 elements that build on that foundation. This is not a comprehensive course on RBPS. It is an introduction such that you will be able to go deeper into the subject as and when that is necessary. This course is primarily concerned with the engineering aspects of process safety, but RBPS is an essential part of the process safety context in which we work. In this section, we will discuss inherently safer design at the fundamental level. We discussed the principles of ISD in core. Applications can be difficult when we get past the relatively obvious improvements. For the learning objectives in this section, we will consider ISD applications rather than just the principles in order to get a better appreciation for how it can practically be used. The objectives: first, describe the use of ISD in upstream, midstream, and downstream assets. Principles are, of course, the same. Applications are significantly different. We will also explain ISD applications at different stages of the facility life cycle. It can be used from the earliest stages clear through to decommissioning. And we will apply ISD to the ongoing exercise that we began in the risk analysis section. There are some questions that we need to consider. Are we really reducing risk, or are we just moving it? There's little benefit in improving inherent safety in one area if the changes that we make are making it worse in other areas. So we do not want to reduce one risk by increasing another. We will consider some possible ISD considerations in the upstream, midstream, and downstream facilities, and, as we said, across the entire life cycle. We will also consider inherently safer design and chemical plant security and safety, written by the Center for Chemical Process Safety for the United States Senate Environment and Public Works Committee.